In the United States, the National Electrical Code, or NEC, has requirements for labeling conductors in electrical panels. All conductors, and that includes phases, neutrals, grounds, and equipment grounding conductors, must be identified with color codes or other approved means. The handles of circuit breakers must be clearly labeled with the circuit they protect. The cable sizes for each circuit must be listed on the schedule. A schedule listing all circuits and their corresponding cable sizes, conductor colors, and breaker numbers must be posted in the panel cover. Therefore, the cable labeling requirements in Barbados are similar to those required by the NEC in the USA. Combination meters, which include a disconnect switch on the main entrance, are not commonly used in the USA. Instead, disconnect switches are typically installed separately from the meter. Separate disconnect switches provide greater flexibility in terms of service and maintenance. To further elaborate on the National Electrical Code requirements for electrical panel labeling, let's break down each aspect. Firstly, conductor identification is paramount. The NEC mandates that all conductors within an electrical panel must be clearly identified. This includes phase conductors, neutral conductors, grounding conductors, and equipment grounding conductors. The primary method of identification is through color coding. Specific colors are assigned to different types of conductors to ensure easy recognition and prevent confusion during installation, maintenance, or troubleshooting. Secondly, breaker labeling is essential for safety and convenience. Each circuit breaker in the panel must be clearly labeled to indicate the specific circuit it protects. This labeling should be durable and easy to read even in low light conditions. Accurate breaker labeling allows electricians and homeowners to quickly identify and de-energize circuits as needed, reducing the risk of electrical shock or damage to equipment. Thirdly, cable size listing is a crucial aspect of panel schedules. The NEC requires that the panel schedule include a list of cable sizes for each circuit. This information is vital for determining the appropriate ampacity of the circuit and ensuring that the wiring is properly sized to handle the expected load. Including cable sizes on the panel schedule simplifies future modifications or additions to the electrical system. Fourthly, the panel cover schedule serves as a comprehensive reference for the entire electrical panel. This schedule must be posted in a conspicuous location, typically on the inside of the panel cover. The schedule should list all circuits, their corresponding cable sizes, conductor colors, and breaker numbers. It should also include any relevant notes or warnings about the electrical system. The panel cover schedule provides a quick and easy way to understand the configuration of the electrical panel and ensures that important information is readily available to anyone working on the system. The NEC emphasis on clear and accurate labeling is driven by a commitment to electrical safety. Properly labeled conductors and breakers reduce the risk of accidental contact with live circuits, preventing electrical shock and potential injuries. Clear labeling also simplifies troubleshooting and maintenance, allowing electricians to quickly identify and resolve electrical problems. In addition to the NEC requirements, some local jurisdictions may have their own specific rules or regulations regarding electrical panel labeling. It's important to consult with local authorities to ensure compliance with all applicable codes and standards. Regarding combination meters, while they are not commonly used in the United States, it is worth exploring the reasons why separate disconnect switches are preferred. Firstly, separate disconnect switches offer greater flexibility in terms of service and maintenance. With a separate disconnect, the entire electrical panel can be de-energized without affecting the meter itself. This allows electricians to safely perform maintenance or repairs on the panel without having to coordinate with the utility company. Secondly, separate disconnect switches provide an additional layer of safety. In the event of an electrical emergency, the disconnect switch can be quickly turned off to cut power to the entire building. This can help to prevent further damage or injury. Thirdly, separate disconnect switches are often required by local codes or utility regulations. Some jurisdictions mandate the use of separate disconnects to ensure that the electrical system meets specific safety standards. In summary, while combination meters are used in some parts of the world, separate disconnect switches are the norm in the United States due to their increased flexibility, safety features, and code compliance. The National Electrical Code places a significant emphasis on proper labeling and documentation of electrical panels. These requirements are designed to promote electrical safety, prevent accidents, and ensure that electrical systems are properly maintained. By adhering to the NEC guidelines and any local regulations, electricians and homeowners can create safe and reliable electrical installations. Now let's delve a bit deeper into the specific aspects of conductor identification within an electrical panel as mandated by the National Electrical Code. The NEC provides detailed guidelines on how to properly identify conductors, ensuring that individuals working on electrical systems can quickly and easily distinguish between different types of wires. The primary method of conductor identification is through color coding. The NEC specifies a set of standard colors for different types of conductors. For example, black and red are typically used for phase conductors in a 120 or 240 volt system, while blue is often used for phase conductors in a 480 volt system. White is reserved for neutral conductors, and green is used for grounding conductors. This color coding system allows electricians to quickly identify the function of each conductor without having to trace it back to its source. In addition to color coding, the NEC allows for other approved means of conductor identification. This may include the use of color tape, heat shrink tubing, or other marking methods. However, it is important to ensure that any alternative identification method is durable and easily visible. The NEC also requires that conductors be identified at all termination points. This means that the color code or other identification must be visible where the conductor connects to a circuit breaker, terminal block, or other electrical component. This ensures that the identification is maintained throughout the entire electrical system. Proper conductor identification is essential for several reasons. Firstly, it helps to prevent accidental contact with live circuits. By clearly identifying phase conductors, electricians can avoid touching energized wires, reducing the risk of electrical shock. Secondly, it simplifies troubleshooting and maintenance. When an electrical problem arises, properly identified conductors make it easier to trace circuits and identify the source of the issue. Thirdly, it ensures compliance with the NEC and other applicable codes. Adhering to the NEC conductor identification requirements helps to ensure that electrical installations are safe and reliable. Now let's consider the importance of breaker labeling in electrical panels. As previously mentioned, the NEC mandates that the handles of circuit breakers must be clearly labeled to indicate the specific circuit they protect. This requirement is crucial for safety, convenience, and efficient troubleshooting. There are several methods for labeling circuit breakers. One common approach is to use pre-printed labels that adhere to the breaker handles. These labels typically include a description of the circuit, such as kitchen receptacles or living room lights. Another method is to use a label maker to create custom labels. This allows for more flexibility in terms of the information included in the labels. Regardless of the method used, it is important to ensure that the labels are durable and easy to read. They should be able to withstand the heat and humidity that can be present in electrical panels. The label should also be large enough to be easily read from a distance. In addition to the circuit description, the labels may also include other relevant information such as the breaker number, the wire gauge, or the connected load. This additional information can be helpful for troubleshooting or making modifications to the electrical system. Proper breaker labeling is essential for several reasons. Firstly, it allows electricians and homeowners to quickly identify and to energize circuits as needed. This is particularly important in emergency situations such as a fire or electrical shock. Secondly, it simplifies troubleshooting and maintenance. When an electrical problem arises, properly labeled breakers make it easier to isolate the affected circuit and identify the source of the issue. Thirdly, it prevents accidental overloading of circuits. By knowing the connected load for each circuit, users can avoid plugging in too many devices, which can lead to overheating and potential fire hazards. The NEC requires that breaker labels be updated whenever changes are made to the electrical system. This includes adding new circuits, removing old circuits, or changing the connected load. Keeping the breaker labels up to date ensures that the electrical panel remains a safe and reliable source of power. Let's now examine the significance of cable size listing on the panel schedule. The NEC requires that the panel schedule include a list of cable sizes for each circuit. This information is vital for determining the ampacity of the circuit and ensuring that the wiring is properly sized to handle the expected load. The ampacity of a cable is the maximum amount of current it can safely carry without overheating. The NEC provides tables that list the ampacity of different types of cables based on their size, insulation type, and installation method. When determining the appropriate cable size for a circuit, it is important to consider the connected load. The load is the amount of current that the circuit is expected to draw under normal operating conditions. The cable size must be large enough to handle the load without exceeding its ampacity. Using undersized cables can lead to overheating, which can damage the insulation and create a fire hazard. In addition to the load, it is also important to consider the voltage drop in the circuit. Voltage drop is the decrease in voltage that occurs as current flows through a cable. Excessive voltage drop can cause appliances and equipment to malfunction. The NEC provides guidelines for limiting voltage drop in electrical circuits. Longer circuits or circuits with heavy loads may require larger cable sizes to minimize voltage drop. The panel schedule should clearly indicate the cable size for each circuit. This information should be readily accessible to anyone working on the electrical system. The cable size should be listed using the appropriate wire gauge designation, such as 14 American wire gauge, 12 American wire gauge, or 10 American wire gauge. Including cable sizes on the panel schedule simplifies future modifications or additions to the electrical system. When adding a new circuit, electricians can quickly determine the appropriate cable size based on the connected load. This helps to ensure that the new circuit is safe and reliable. The practice of posting a panel cover schedule and adhering to the NEC standards for electrical panel labeling is critical for ensuring safety, facilitating maintenance, and promoting code compliance in electrical installations. The panel cover schedule serves as a comprehensive reference for the entire electrical panel, providing essential information about each circuit and its associated components. This schedule is typically posted on the inside of the panel cover, making it readily accessible to electricians, maintenance personnel, and homeowners. The panel cover schedule should include a detailed list of all circuits in the panel, along with their corresponding breaker numbers, cable sizes, conductor colors, and connected loads. This information allows users to quickly identify the function of each circuit and determine its capacity. In addition to the circuit information, the panel cover schedule may also include other relevant details, such as the voltage of the system, the location of the main disconnect switch, and any special instructions or warnings. This comprehensive information ensures that users have a complete understanding of the electrical system. Proper maintenance of the panel cover schedule is essential. Whenever changes are made to the electrical system, such as adding new circuits or modifying existing ones, the panel cover schedule should be updated accordingly. This ensures that the schedule remains accurate and reliable. The NEC provides specific requirements for the content and format of the panel cover schedule. These requirements are designed to ensure that the schedule is clear, concise, and easy to understand. Adhering to the NEC guidelines helps to prevent confusion and errors. The panel cover schedule should be legible and durable. The information should be printed in a clear font and protected from moisture and other environmental factors. This ensures that the schedule remains readable over time. Posting a panel cover schedule is a simple but effective way to improve the safety and efficiency of electrical installations. By providing clear and accurate information about the electrical system, a panel cover schedule helps to prevent accidents, simplify troubleshooting, and ensure code compliance. Let's move on to the differences between using combination meters and separate disconnect switches in electrical systems. In the United States, separate disconnect switches are more commonly used than combination meters, which integrate the meter and disconnect into a single unit. This preference for separate disconnect switches stems from several factors, including flexibility, safety, and code compliance. Separate disconnect switches offer greater flexibility in terms of service and maintenance. With a separate disconnect, the entire electrical panel can be de-energized without affecting the meter itself. This allows electricians to safely perform maintenance or repairs on the panel without having to coordinate with the utility company. In contrast, combination meters require the utility company to disconnect the power before any work can be performed on the electrical panel. This can be inconvenient and time-consuming. Separate disconnect switches also provide an additional layer of safety. In the event of an electrical emergency, the disconnect switch can be quickly turned off to cut power to the entire building. This can help to prevent further damage or injury. Combination meters may not offer the same level of accessibility or responsiveness in emergency situations. Furthermore, separate disconnect switches are often required by local codes or utility regulations. Some jurisdictions mandate the use of separate disconnects to ensure that the electrical system meets specific safety standards. Combination meters may not be compliant with these requirements. The choice between combination meters and separate disconnect switches also depends on the specific application and the preferences of the electrical designer or installer. In some cases, combination meters may be a more compact and cost-effective solution. However, separate disconnect switches generally offer greater flexibility, safety, and code compliance. In summary, while combination meters are used in some parts of the world, separate disconnect switches are the norm in the United States due to their advantages in terms of serviceability, safety, and regulatory compliance. The National Electrical Code (NEC) plays a vital role in establishing standards and guidelines for electrical installations in the United States. Compliance with the NEC is essential for ensuring the safety and reliability of electrical systems. The NEC is a comprehensive document that covers a wide range of topics, including wiring methods, overcurrent protection, grounding, and equipment installation. It is updated every 3 years to reflect changes in technology and best practices. The NEC is not a law, but it is widely adopted by state and local jurisdictions as the basis for their electrical codes. This means that compliance with the NEC is often legally required. The NEC is developed by the National Fire Protection Association (NFPA), a non-profit organization that is dedicated to reducing the risk of fire and other hazards. The NEC development process involves input from a wide range of stakeholders, including electricians, engineers, manufacturers, and regulators. This ensures that the NEC is technically sound and reflects the needs of the electrical industry. The NEC is organized into chapters, articles, and sections. Each section provides specific requirements for a particular aspect of electrical installations. The NEC also includes tables and figures that provide additional guidance and information. Electricians and electrical contractors are required to be knowledgeable about the NEC and to comply with its requirements. Failure to comply with the NEC can result in fines, penalties, and even criminal charges. The NEC is an essential resource for anyone involved in electrical installations. By following the NEC guidelines, electricians can ensure that electrical systems are safe, reliable, and code compliant. The information provided in this discussion is intended for general educational purposes only and should not be considered as a substitute for professional advice. Always consult with a qualified electrician or electrical engineer before undertaking any electrical work. Working with electricity can be dangerous, and it is important to take all necessary precautions to protect yourself from electrical shock and other hazards. Before starting any electrical work, always disconnect the power to the circuit you will be working on. Use appropriate personal protective equipment, such as insulated gloves and safety glasses. If you are not comfortable working with electricity, hire a qualified electrician to do the job. Electrical work should only be performed by individuals who are properly trained and licensed. By following these safety guidelines, you can minimize the risk of electrical accidents and ensure that electrical installations are performed safely and correctly.